Welcome to Easy Gates Instrumentation Gate 22 Solutions. Next problem, question number 43. Yes, based on a polar plot given as an aqueous plot for a stable open loop system G of j omega. So given G of S is stable, so its polar plot is given when omega varies from 0 to infinity. Okay, so you need to comment on the stability. You consider what is given as GH of j omega. So any mentioning? Yes, but still we are commenting on stability means it should be the loop transfer function. So what is given is the polar plot of GH of j omega. Take that way. It is found to intersect a unit circle with center at the origin. Okay, so at point P. Okay, that means the polar plot is found intersecting a unit circle with a center at the origin at point. Okay, so the point P is mentioned. What is the point P? Point P is real and imaginary is mentioned. Point P is mentioned, that is minus 0.77 real, negative real, minus j.64. Let me take. Okay, so this is where the plot is intersecting the unit circle. Okay, then the same plot is the points Q and R lie in the G of j omega, and assume values of Q is given. So where is the Q? Okay, Q value is given. Q is 14.4 plus J0. So anyway, there is neither gain crossover nor phase crossover. We do not to probably play there. We'll see if record will play there. Okay, so then R is given. So R is the point where the polar plot is intersecting negative real axis, that is minus 0.21 plus J0. Let me take. So that's minus 0.21. So minus point, this point R is talking about a phase crossover point, and point P is talking about the gain crossover point. So let me take this. So let me take this GH of j omega's polar plot like this. Something like this. So this is where it is cutting the unit circle. So this point is given as minus 0.21. Let me take. So this is the point where it is cutting the unit circle. That point is mentioned as, so it is given as minus 0.77 plus, let me check. Okay, it is cutting the unit circle. So I don't know the phase angle of it, and I have to confirm first whether the magnitude of this is 1 or not. So minus 0.77 minus j.64. So let me confirm, root of 0.77 square plus 0.64. Okay, is equal to 1 or not. Okay, and 0.64 square it is. Okay, so 0.77 square plus 0.64 square is equal to 1.0025. So it's approximately the gain crossover point. At gain crossover, let us find the phase angle contributed. So what is this phase angle? Let me say, check. So this is the phase angle I'm looking for. So this phase angle I'm looking for. Okay, so this is the gain crossover point. So what is the phase angle? So tan inverse of 0.64 by 0.77. So that's a phase angle. So I discarded the negative. I'm going for only this, not this. Okay, this means with the negative sign, you have to add minus 180. I'm going for only this angle. Okay, so you know the total is 180. So I'll go for only this angle. So tan inverse of it is 0.64 divided by 0.77 will be the phase angle. So shift tan answer will be 39 point. This angle is going to be 39.73. So that means at gain crossover, what exactly the angle we have is at gain crossover, we have a loop phase lag of this much. What is the loop phase lag? It is 180. So minus 180. That's a loop phase lag we have. So it is minus 140.26. So I can take it as 27 degree, approximately 0.3 also I'll take. So this is the loop phase lag. Loop phase lag is 140.27 degree. That means, so the system is absolutely stable. I can have positive phase margin. How much phase angle I can, phase lag I can add means I can add this entire. So this is going to become my phase margin. So let me check. The problem is talking about the phase margin and the gain margin. So he's helping me by asking phase margin. Let me check. Okay, only one. Okay, there are two. So 39.7 given in option A and B. So it is plus 39.7. So that means we are adding lag only. System is, yes, even you know one thing, phase margin, gain margin positive means system is absolutely stable. Already you know it is absolutely stable. So 39.7. So it is going to be either option A or B. So we have to find the gain margin as well. So for that, this point is given, this point is given. That is our phase crossover point. So at phase crossover, what is our loop gain? So loop gain should be equal to what? 1 for marginal stability. What is our loop gain? Loop gain is only 0.21. So that means I can increase the loop gain by how many times to make it 1, since the gain margin is not given in decibels. But anyway, the system is absolutely stable here as well, because the loop gain is less than 1 at phase crossover. Then how much amount of gain I can increase, how many fold I can increase to make my system marginally stable is going to be my gain margin, usually expressed in decibels, but in this case, it is not given in decibel. Let me go for that ratio. It's simply inverse of that 0.21. That means you have to take it k into 0.21. So what k will make it 1? That's what it means. You have to remember something like this. It's a loop where you have a k. So you're keeping the k is equal to 1. The loop gain is there given. Okay, you are at phase crossover. It is nothing like 0.21 at an angle minus 180. 0.21 at an angle minus 180, or at phase crossover. So what k will make the gain crossover also to happen at this phase crossover to make the system marginally stable. So that means the loop gain has to be made 1. So k into 0.21 should be equal to what? 1. So k should be 1 by 0.21. That's what your margin for gain adjustment is. Okay. So what is that? The gain margin is 1 by 0.21. So 0.21 inverse will be your gain margin. So that is nothing but 4.76. Okay. 2. But usually it should be expressed in decibel by habit, but he missed it. So expected is 20 log of this only. Okay. So it is not mentioned there. Okay. But still you can go for the right answer. So it should be 13.55 or 56 decibels. It is not mentioned. Usually we look for 13.56 decibels of gain margin. Not there. Okay. Yes, given instead 4.76. So better. Okay. You can take a call. Okay. So you should feel that he simply given how many fold you can increase your gain. So this is, yes, reasonable. Sometimes papers earlier happened also given something like this, gain margin without decibel. So you can accept and give the answer as option A. The phase margin is 39.7. Positive phase margin, positive gain margin. The given system is absolutely stable system. Okay, yes. So that's a fundamental bipolar plot.